use Google Sheets in the instructions in like the answer portion, but you really don't need Google Sheets. You could actually just use these values here and then use the formula for the confidence interval of a population proportion. If it's off by like 1/100th though, then I guess that does mean we'd have to use some sort of calculator like Google Sheets. But I'm pretty sure if you just plug in, I'll do both. I'll plug in these numbers and I'll also use Google Sheets to show you. Okay, so basically what this problem is asking you to do is to calculate a confidence interval between these two proportions, okay? And they just want us to report the upper bound. And a confidence interval, remember you get two numbers, okay? You make a confidence interval like this. There's a number that goes in this blank, and then there's a number that goes over here. This number that goes here is your upper bound, and then this would be your lower bound. We would be 90% confident that the true difference between those two proportions is between those two numbers. Okay. So before we construct that confidence interval, we gotta find out what a z-score is for this confidence interval. The z-score always depends on your level of confidence. They say 90% confidence, so that means they want to have 90% of the area under the normal distribution here, okay, if we're using the z-score. So that means that there's 5% for each tail, right? There's 5% over here under the normal distribution, and then there's 5% over here under the normal distribution. So with traditional z-score tables, and what we're going to see in Google Sheets, it tells you the area to the left of a certain z-score. So to find out what this z-score is up here, the upper cutoff, then we need not 90% to the left. We need 90% plus this 5%. We need a z-score for 95% of the area to the left. So to do that, you can open Google Sheets or Excel, type in equals, and then I think it's norm.s.inv. Or if you're on Excel, it might be equals norm.s.inv. Both of those, I think, do the same thing, norm.s.inv. And we said we're not going to type in 0.90, we're going to type in 0.95 because we want 95% of the area to the left. And look, that's the z-score they have here, except the z-score they have here comes from like a hand table that's just rounded. So that's the z-score. Everything else here you get from the problem. That doesn't come from Google Sheets or anything like that. Okay, so just to help you with where those numbers come from, if you read through the problem, it says that married men are supposed to be the first group, so n sub 1. N sub 1 is going to be 286 because the number of samples from the married group is 286. N sub 2 would obviously be 307, the single group. P hat sub 1 means the sample proportion that were successful or that had the characteristic that we're studying. It says in the problem that 157 married men, so we take 157 married men responded positively. So take 157, divide by the sample size. That makes 0. Blah, 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 bunch of stuff. And then for p hat underscore 2, that just means the sample proportion from group 2. We do the same thing. There was 102 that responded positively. Divide by the 307 total that were in that group. So if we cut that decimal off a little bit, not too far, but a little bit, that's our p hat 2. And now you have all the numbers to plug in here, okay? So you want to take out, remember the z-scores over here. You want to write this down on paper, and you want to do it one step at a time if you have trouble with the order of operations, okay? I'm about to do it all with a calculator here, but again, what you would want to do on paper if you have trouble visualizing how to plug this into calculators, plug in the number for p hat 1, 0.5489, plug in n sub 1, plug in each of those numbers. Oops, one second. But I'm going to do it all with a calculator right now. 286. Just so you can check to make sure you get the same thing I get. P hat 2, 0.332248. Oops, I got to write this down. So what that number is, that's what I got for the first fraction. Okay. For the second fraction, 0.332248. Let's copy that to the clipboard. I'm doing 1 minus that decimal number times p hat 2 divided by 307. That's what I got for the second fraction inside the square root. So if I add those together, I'm going to do this plus the other fraction, and then I have to take a square root of it. This is what I got after simplifying the square root. I'll write that down so I don't lose it. I'm supposed to take z and multiply to what I got from the square root. Okay. So my z is 1.644854, I'm rounding there, times what I got from my square root. So there's my margin of error. This everything to the right of the plus or minus symbol I just got to be 0.065 repeating. I'm going to squeeze that in right up here. Oh, maybe I can't. Squeezing it down here. Yeah, well, let me do it anywhere. I'll just write it over here. That's what I got when computing the margin of error. So it's p hat 1 minus p hat 2. And just make sure on those problems, if you have something similar, that you follow the order that's specified in the problem. This problem said married men was p hat 1. So p hat 1 comes first. I just changed the sign. It'd be instead of positive to negative. But actually, no, it won't matter either way. Well, yes, it will. It'll change it from positive to negative. Okay. All right, so what I did was I took p hat 1 subtracted by p hat 2, did the parentheses, and now if I want my upper bound, I want to add the margin of error to it, the 0.0655555 that I just got. So 0.282 is what I got for a margin of error when rounded to 3 decimal places.